Hello there, this is Robert Kornacki, CSO at DC Spark. In this video, we're going to take a look at the Plutus Voting smart contract for the Catalyst proposal. This repo effectively encompasses the entire voting smart contract and has the on-chain contract, on-chain smart contract, off-chain code to run the on-chain contract and the endpoints to support that. Including in that, we also have tests, which are both positive tests verifying functionality and also bad acting or malicious tests, which try to verify that the code implemented is actually secure and doesn't allow people to, do bad things such as steal money or put fake votes or yada yada. In the README of the repo, so when someone clicks onto the repo, we have the protocol defined on what the voting dApp actually does and how it works. So in our case, we have a treasury, so a set of tokens slash assets locked up in a treasury UTXO under the treasury script, and the treasury validator script or smart contract allows votes to take place. And so those votes can either decide on how to spend the treasury funds, and or because you can move funds, you can also move the funds to a new treasury by voting to move all of the treasury to a different smart contract address and thus validator script. So effectively, this is a voting dApp which allows people to have a DAO, have some sort of treasury for a DeFi protocol, or anything in between, where there's a bunch of tokens held up in a treasury that's smart contract locked, and then a quorum is required to vote. This is different compared to the upgradability smart contract, because in that one we implemented a straight multi-sig, while here we're using tokens to vote. And so people must acquire the vote tokens of this protocol. When someone deploys this, they create their own tokens. And then those vote tokens, whether that's for their DAO, for their DeFi project, a governance token, or otherwise, that token can then be used to vote to spend funds from the treasury. And so in this way, we have this nice design pattern that a lot of projects will want to use. And so pretty much the steps here are setting up a treasury, voting for the desire to spend funds to a specific address, tallying the votes, and then issuing that so then the treasury gets paid and all the voters get their votes back. And so this is effectively the protocol in a nutshell, and this is a pretty nice step forward so that a bunch of dApps and smart contracts can start to integrate voting into their schemes. Plus, this is parallelized where each person votes with their own tokens for a specific proposal to spend funds from the treasury, but they're all voting in parallel. So that means we don't have any throughput problems, we don't need any batchers, scoopers, or aggregators, and still everyone can vote at the exact same time. And so this design focuses heavily on parallelism. Lastly, let's just jump into all of the code so that we can just show off how the repo is set up. We have off-chain code, on-chain code, and utilities. Utilities are just utility functions to make the off-chain and on-chain code more clean to read. In the off-chain code, we have a bunch of different functions which allow you to return votes after they have been submitted, and once the proposal goes through, to tally the votes to see if a specific proposal has enough votes to spend money, and some other useful functionalities for off-chain. In on-chain world, in the smart contract, we have a bunch of useful functions that make it easier to write all the code without it getting too dense. We have the actual voting scripts. So this is the smart contract that when people vote, this is what they will deposit into, and that's what their vote will be locked by. Then we have the treasury script, which is the second smart contract, which is what the actual treasury is locked with, which will be holding all the funds. And so effectively, these two smart contracts are what the entire protocol relies on. And we separated these two into two smart contracts such that we can have the parallelism, which I mentioned, so that we have higher throughput for the voting. Lastly, we have tests with basic scenarios, endpoints, malicious endpoints. Basic scenarios are the positive tests for the fact that there's enough votes to move the funds from the treasury, or there's not enough not enough votes. And then we have malicious endpoints, which are trying to abuse the smart contracts and see that they don't allow people to like steal or change other people's votes and other malicious bad acting things that that could theoretically happen if one were to deploy this in production. And so with all that said and done, we effectively have the on-chain smart contracts, the off-chain code, and everything together with a set of testing positive and negative cases to make sure that everything is working well. Of note, this code is not audited, as we did not receive funding to get this audited professionally, but this is a solid foundation for projects to use, and they can easily adapt this into their own dApps and smart contracts, and then they can go through the process of auditing as well themselves once this goes into more production, and then there's either a path forward, or maybe in future Catalyst proposals, we can also look at having this code audited so that the community has a higher sense of security when using this code for their own cases. And yeah, so that's pretty much everything for this project. Thanks for watching. Have a great day.